Okay, so we're multiplying polynomials. Polynomials sounds very mathematical. What does poly mean? Many. Nomials? Numbers or terms. So the things that you were looking at last night using the distributive property, those were polynomials. So we're going to start off with one like you had last night, just to make sure you know what you're doing here. So if I have 3 times 7x minus 2, this is our basic distributive property, right? Why do we need to do the distributive property? Well, I'll tell you in a minute. So I'm going to take this 3, I'm going to distribute it to the 7x, which means I'm going to multiply it by 7x, and that's going to give me what? 21x. And then I'm going to take 3, and I'm going to multiply it by what? Negative 2, and that's going to get me? Negative 6. You guys are brilliant. I love it. And that's my answer. Now, why is the distributive property important?
So if you get rid of the whole thing,
Because usually a distributive property problem will not just be this on its own. It will be part of a larger problem. Now, there's this little thing in math that we like to talk about. The order of operations, right? Parentheses, exponents, multiplication, division, addition, subtraction. And what's the first letter? Parentheses. When I used the distributive property, what happened to those parentheses?
they went away.
They went away. So in other words, the distributive property takes care of the p, so you can move to the MDOS. So when it's in the middle of a bigger problem, that's the purpose of the distributive property. Okay? All right. So let's move on past that, since I think you can handle distributive property okay. You ready? It's going to get really hard here. Can you handle it? It's just some numbers, don't worry, they won't bite. All right. So some people learned this they learned the process of multiplying this as the word FOIL. You heard of that?
No.
Never heard of that?
No, I've never heard of that.
You multiply the firsts, and then the outers, and then the inners, and then the lasts. Okay? If you haven't heard that word, it's totally fine. Because I'm going to call it the distributive method. Because that acronym only works when you have 2 terms and 2 terms. And we're going to be doing things that don't just have 2 terms and 2 terms. Okay? So it's really a distributive property way of multiplying. Now I'm going to actually show you 2 different ways of multiplying. And you can just pick whichever one you are more comfortable and confident using and use that method. Okay? Now, I tend to always use the distributive method because that right there to me is a piece of cake. So I like doing that over and over again because it makes me feel smart. So I have a parentheses here, and I'm going to take this and I'm going to distribute it to here, but I can only distribute it 1 term at a time. So I'm going to start off pretending that minus 7 isn't there, and I'm just going to take that A and distribute it. Okay? So if I take A and I multiply it by 5A, what does that give me? 5A. I have 2 bases, so I have to add their exponents, don't I? So I have 5A squared. Am I done distributing that A? No, I have to distribute that A to the 1. So A times 1 is positive A. Now am I done distributing that A? Yes. So now I need a different color. This one looks like black, so it's going to look the same on the camera. Hang on. Let me get a different color to hopefully make things a little easier for you to see. Okay, so now I'm going to pretend like the A is not there, and I'm going to take this negative 7 and distribute it. So I'm just using the distributive property twice. So negative 7 times 5A is negative 35A. Negative 7 times positive 1 is negative 7. So I just used the distributive property twice. Now I just need to combine my like terms and I'm done. When we combine like terms, things should be fairly much in order. I have 5a squared. And then what is this going to give me? 1 minus 35. Negative 34a minus 7. And I'm done. Is my polynomial or my answer in standard form? What does standard form mean again? Highest exponent term,
Yeah.
counting down, it's in standard form. So? Your favorite thing to do, I know. 3x minus 4, and then 3x plus 4. Here's our next one. Now this one, I'm going to show you the other method, because like I said, there's two methods. Pick which one makes most sense to you and use that method. This method I'm going to use is called the box method. So I'm going to make a box, and this box is going to have very specific dimensions. You ready? Since this first one has two terms, my box has to have 2 rows. Because I'm going to put that 3x on one of the rows and the negative 4 on another. What do you think I'm going to do with the other one? Those are my columns. So I have 2 terms. I need 2 columns. I give 3x to the first one and 4 to the second one. Do you see my box? Hence the name, the box method. Genius, I know. So now I just need to treat this like a multiplication chart. So 3x times 3x is 9 what? X squared. What's 3x times 4? 12x. What's negative 4 times 3x? Negative 12x. And negative 4 times positive 4? Negative 16, right? Multiplication table.
My bad.
You were on a roll, too.
Now, a lot of people like the box method because when you use the box method, your like terms end up being diagonal from each other, so it's easier to find them and combine them. What do you notice about the like terms in this problem? Negative 12x and positive 12x, isn't that like number 1 on the homework last night?
Yeah.
Right? Negative 12 and positive 12 is 0. So my answer is 9x squared minus 16. Not too bad?
Yeah.
You like the distributive method better?
I think I like the box method.
Okay. Let's see. Next problem. I have 9 total. Because I have to show you what happens when there's more terms in it. I want to show you what that looks like. It's not any more difficult, it's just longer. It just means you have a bigger box with more terms, but it's not any more difficult. So there's that. I forgot to put a little squared there, but those are a little squared outside my parentheses. Now, when we were learning our exponent rules, we liked it when we could just distribute that exponent, right? Can we do that here? No, because that rule said you can only do that if it's all multiplication inside.
Oh.
That darn plus sign screws everything up. I can't do that. So what this means, if this is being squared, I have to actually write this as 4 plus 5x times 4 plus 5x. I have to write it twice, and then I have to use one of my 2 methods to actually multiply that out. Okay? So, since I've shown you both methods, why don't you pick one of those methods and try it on your own and see if you can do it. If you do the box, you need 2 rows and 2 columns. Again, with the box method and the distributive method. Neither way is better than the other. They both get you to the same answer. They're both about the same amount of work. Okay? So just pick whichever one works for you and use it. You don't need to know both, just get to know one really well. So I'm going to do distributive again. I'm going to start off by distributing this 4. So I'm going to pretend like this 5x isn't there. I'm going to take the 4 and distribute it over here. So 4 times 4 is 16. 4 times 5x, 20x, because there's only one x, right? This one doesn't have one. And then I'm going to distribute what? The 5x. So 5x times 4 is another 20x. And 5x times 5x, both positive, gives me positive 25x squared. So, my like terms. Let's see, I'm going to keep the 16 here. Now, I know that you might be tempted to go into standard form by putting the x squared first. Don't stress about that right now. Just keep it in the order that the problem is there. All right? What happens here? Do those guys cancel out like the ones up here did?
No,
No, why not?
because there's no negative.
They're both positive, right? So 20 and 20 is 40x. And then plus 25x squared. And for now, let's just leave it like that, because the point of this exercise is multiplying, not rearranging. So? Okay. Let's see. So do we understand what to do when we have the squared? We have to physically write it twice. That's going to be something that people struggle with. Would you like me to do another one of those? Okay. So here we go. 3x minus 2 squared. Do you want a minute to try it? Go ahead and try it using whichever your preferred method is. I will use the box method this time when I do it. So far, so good? How I wrote it twice. Remember, we cannot distribute that exponent. Why?
Because there's subtraction.
As soon as there's a plus or minus in there, we have to write it twice. So I have 3x minus 2 and 3x minus 2. So what's 3x times 3x? 9x squared. What's 3x times negative 2? Negative 6x. What's negative 2 times 3x? Negative 6x. And what's negative 2 times negative 2? Positive 4. Are the like terms still diagonal from each other?
Yes.
Good, that's helpful. I don't have to search for them. So how should I write my answer? I have 9x squared. And then what? I combine those two. What's negative 6 and negative 6? Negative 12. So I have minus 12x, and then plus 4. Done. Not too bad. Okay. Now we're going to bump it up again. We're almost done, though, because you know I said there's only 9. So we're getting there close. How is this one different? How did I increase the difficulty here? I put a what? There's an exponent inside here. That's one way. What's another way? There's another term. It's not just 2 times 2. There's 2 times 3, right? 2 numbers times 3 numbers. So I'm going to do this one. Let's see. Raise your hand if you prefer distributive method. Raise your hand if you prefer the box method. Okay. I'm going to do this one using the distributive method. If you like the box method, you use the box method. You should be able to see where it matches up. The next one I will use the box method on. Okay? Try and show both of you. So, how many things do I have to distribute? I still only have 2 things to distribute, correct? So, actually, you know what? I lied, sorry. I'm going to use the box method on this one and the distributive on the next one. If you use the distributive method, go ahead and use the distributive method. You will see where your terms play into that. I want to show you the box method because this one has a different number of terms in each. So I want to make sure you can set it up correctly. So, if I set up this box method, I need room for 3p and 8. What do I need this way? 4p squared. What else? Negative 5p and negative 8. Notice I'm keeping the signs with them. So this time I have 3 columns, so my little box has grown a little bit. So let's multiply. 3p times 4p squared. What does that give me? 3 times 4 is 12. What's p times p squared? P to the what? Third? What's 3p times negative 5p? Negative 15p to the second. Right? P times p is p squared. 3p times negative 8. Negative 24p. So far, so good? Next row. 8 times 4p squared. 32p squared, right? 8 times negative 5p, negative 40p. And 8 times negative 8, negative 64. Are your like terms diagonal? P squared and p squared. P and p. They are still diagonal from each other. If you use the distributive property or the distributive method, you still had these same 6 terms just lined up. All right? So let's see, what's my final answer going to be? It's going to be 12p to the third, 32p squared minus 15p squared. What's 32 minus 15? Do I need my calculator? 32 and negative 15 is 17p squared. That's a positive 17p squared. Negative 40 and negative 24 is negative 64p. And then I have minus 64 at the end. And that's what my answer should look like. Yep, they get, the bigger they get in the problems, the longer your answer gets. Okay? But it's still the same thing. It just means you have a few more things to multiply in there and a few more like terms to combine. When they get bigger, I actually think the box method is a little bit easier. Because if you use distributive method, you could have terms written here, 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 here. You could have an entire line of terms, and trying to find the like terms gets a little tedious. Okay? All right, what number are we on? 7. All right. Whew. 3 times 3, right? 3 terms times 3 terms. So if you're going to do box method, you need both 3 rows and 3 columns, right? I'm going to show this one using distributive method, though. So I'm going to pretend that both of these terms don't exist, and I'm just going to look at that n squared and distribute that guy. So the n squared, multiplying it first by 5n squared. What does that get me? 5n to the 4th. Yep. And then if I take that n squared and I multiply it by 6n, what do I get? Plus 6n to the 3rd, right? 2 and 1 is 3.
Okay.
And then n squared times negative 7 would be negative 7n squared. Done with that n squared. Where do I go next? I move on to the negative 3n. Let's distribute that guy. Negative 3n times 5n squared. Negative 15n to the third. Negative 3n times positive 6n is negative 18n squared. And negative 3n times negative 7, positive 21n. Now what? I got to distribute the 5. I have one more thing I have to distribute, don't I? 5 times 5n squared is 25n squared. There's no n there. There's an n squared. That's n squared. 5 times 6n, 30n. And finally, 5 times negative 7 is negative 35. Do you see what I mean about how using the distributive method you could have terms all the way across your paper? It's not that bad, but I think the box method might keep it a little bit tamer. Okay? Because what do I have to do now? Combine like terms. Thankfully, if you write neatly enough, things should be fairly close to each other. For example, 5n to the 4th, there's only one of those. Okay? Now let me look at the end of the thirds. Here's an end of the third. Here's an end of the third, and that's it. So 6 and negative 15 is negative 9. So I have negative 9 n to the third. Done with those guys. What do I combine next? The n squareds. I got one here, here, and here. So let's see. Negative 7 minus 18 plus 25. Whoa, 0. What happened? What did those two together give you? Negative 25 and positive 25. They cancel each other out. So they just drop out. And I just move on. So I have 21n and 30n would be 51n. And finally, negative 35. That is as hard as they get today. Okay? We good? All right, last two problems. Use whichever method you want to solve it. And this one I am being a little bit mean because, what did I do? I put another letter in there. It's my job. That's like the best part of teaching is watching you suffer. No, I'm just kidding. It's totally not. I'm just kidding. It's totally not. However, I do enjoy watching you struggle a little bit with it and then seeing that light bulb turn on when you finally get it. This one I was nice to you, though. All right, choose either method and do both of those. I will do one of them with the box method and one of them with the distributive method.
Yes, yes. 8 should be distributed.
Okay, I can do number 8 distributive and number 9 box.
Yes.
It is. What's x times y?
It's XY.
Mm-hmm.
Yeah. That's it?
Mm-hmm. That's it. No need to overthink it. It's just xy. So 2x times negative 6x is negative 12x squared, right? And 2x times 4y, well, 2 times 4 is 8, and x times y is xy. What is negative 8y times negative 6x? Well, negative 8 times negative 6 is positive what? $48. What's y times x? Yx, but I would call it xy again because it's going to match that. Okay? Makes it easier to see that like term. And then negative 8y times positive 4y, negative 32 y squared. So, where are my like terms? Right there in the middle. So I have negative 12x squared plus what? 8 plus 48 is 56xy, and then minus 32y squared. Yep. I like showing you things that look a little difficult, but then showing you that they're really not that difficult. Yep, exactly. All right, box method. Here we go. I need a 2x2 box, right? Again, you don't need to know both methods. Just use the one that makes the most sense to you. So negative 2x and negative 1, and then negative x and positive 3. There's a lot of negatives here, aren't there? All right, negative 2x times negative x. What does that get me? Negative times a negative is a positive. 2x times x is 2x to the second, because there's two x's. Negative 2x times positive 3 is negative 6x. Negative 1 times negative x, positive 1x, or just x. And negative 1 times positive 3, negative 3. Are my like terms still on the diagonal? They should be. They are because everything's in standard form here on each side. So let's see, I have 2x squared, and then what? 1 minus 6 would be minus 5x, minus 3, done, easy peasy. Yeah? All right, so here comes your homework. Happy studying.